In the previous class, we understood important aspects of the MapReduce. MapReduce is a programming model for the distributed processing. And before MapReduce, we learned a component for the distributed storage. Which is that, Anna? Which is the component for distributed storage? Anna, thinking? Can you guys hear me? Hello?
Yes, sir.
Yes, sir.
Okay, Anna is still trying to. Okay. Yeah, Parveen. Which is the component for the distributed storage?
HDFS. Sir.
HDFS. Okay, HDFS is a component for the distributed storage. Okay, so we learned two important components in Hadoop ecosystem. One is HDFS, which is for the distributed storage. Another one is MapReduce, that is for the distributed processing. Now we already have a MapReduce for the distributed processing, and also we have one more component called Spark. We have one more component called Spark, which is also used for the distributed processing. Aren't you wondering, there is already a component for distributed processing. Why are we using Spark? What do you think, Shabna? Why Spark? Vineet, we already have MapReduce.
Sir, actually, when you told us MapReduce has two phases, mapper and reducer. So that whole data must be visualized in the form of map and mapping and reducing. So I have read somewhere that it's a very complicated and a very lengthy process. That's why we needed a less complicated kind of thing, that is Spark.
Wonderful. Thank you so much. So MapReduce, even though it was a de facto one of the important component or a programming model for distributed processing, there were some shortcomings in MapReduce. Some of the points are already mentioned by our Vineet. Let us look at them one by one. Okay. One of the very, very important shortcoming is any data processing task need to be visualized in a map and reduce key value pair. Any data processing task need to be visualized in a key value. Maybe it is easy for the people who are a Java geeks, but for a people who are using a SQL, for the commoners, it may be difficult. It may not be very intuitive, right? So are you guys able to get it? So will you be able to visualize the filter as a key value pair, right? So it is difficult to intuitively visualize all the data processing tasks as a key value pairs, as a MapReduce computations. Okay, that was one of the shortcoming of the MapReduce. One more very, very important thing is MapReduce used to rely on reading the data from HDFS task. Let us say you have a processing to be taken care. Okay, that processing of data is there in this particular disk. It is which color it is? Which color it is, Vineet?
It's golden something, sir.
Golden yellow.
Yellow.
Golden yellow, right? Is it correct? All the girls in the group?
Yes, sir.
Golden yellow. Okay. So now the data is there here. It involves two steps. To processing involves two steps, iteration 1, iteration 2. Now, after performing the iteration 1, the data, that after iteration 1, the intermediate results, they need to be MapReduce used to write that into a disk, and that actually need to be funneled into iteration 2. Now, the intermediate results are written into the disk and read from the disk. Okay. So you may ask a question, why is that a shortcoming? That is a shortcoming because we are not dealing with a small amount of data. We are dealing with a TB of data. So when you have to write a TB of data and read from a disk, it takes lot of time. We're not talking about a KB. We're not talking about even MBs. We are talking about GBs, TBs, and even the PBs, right? So when you are dealing with so much of data, if MapReduce is writing the intermediate results to the disk and reading from the disk, that takes a lot of time. That is also one of the shortcoming. Okay, that is also one of the disadvantage. Okay. Then one more very, very important aspect of the MapReduce was those who know Java only they can work in the MapReduce, because you cannot code in any other language apart from Java in MapReduce. Okay. How many of you guys love Java here? I'm not hearing any voices. That means say that none of you love Java. Okay. Right? So, because especially the people who are working on the data, most of them are well versed with the SQL or SQL. Okay. So, it may be difficult for every person who is associated with the data to master the Java and work on Java in MapReduce. So, that also happened to be one of the shortcomings. Basically, having support for only one language is a shortcoming. Is everybody following me? Anna,
Yes, sir.
Mutabina, everybody is following me?
Yes.
Are you guys with me?
Yes,
Are
sir.
you able to follow why I'm talking about why Spark came into existence? Spark came into existence because of the shortcomings of the MapReduce. And I'm discussing shortcomings of the MapReduce. Okay? You guys are with me? Okay. So one more important thing is the MapReduce do not have a, at least during that time, it was not having a interactive shell to immediately type something and see the results. And also, it didn't have a support for the streaming. Streaming is the data is continuously flowing. The component has to allow the analysis of the continuous flow of the data. Okay, that is not supported in MapReduce. Okay, so these are the some of the important shortcomings which led to the development of the Spark. Any questions here from anyone?
Sir, no support for streaming means?
Basically, MapReduce is a component which will allow you to analyze only the batch processing. Means batch processing means the data which is already stored somewhere, stored in a database or a data store or a HDFS. If the continuous data is flowing, MapReduce cannot support that. Streaming means like the way you stream the movies, right? Like
Okay, understand, sir.
when you watch a movie Netflix, do you have all the movies in your TV? No,
No,
only
sir.
that title will be there. When you click on that title, that movie will be streamed from some of the nearest data center of Netflix. Okay, so like that, assuming that, let us say somebody has to analyze the continuous tweets during the IPL matches. Okay, tweets. People are tweeting, right, during the IPL matches, or during the football matches, during the soccer matches, during the basketball matches. Okay, so as in when the data is flowing, MapReduce doesn't have a capability to analyze it there. Okay, it can analyze or process only the data which is already existing in a data store. Got it, Shabna?
Yes, sir.
Okay, wonderful then. Now that we understood the shortcomings of MapReduce, what are the advantages of the Spark? What are the advantages of the Spark? Anyone?
So, it can be suitable for both batch processing and live streaming as well.
Very good, very good, very good. Any other thoughts from anyone?
It supports other language than Java.
Very good, Vineet. Awesome. Anyone else? Others? Not.
And
High processing speed.
Yeah, go ahead,
It,
Anna. What did you say?
So high processing speed.
it must.
High processing. Yeah, okay. Processing speed is better. Okay. Okay. Wonderful. So let us look at them one by one. Okay. So one of the very, very, very important aspect of a Spark is it is an expressive programming language. Means it has more than 20 highly efficient distributed operations. You can pipeline them one after another to perform the data processing task. Means those operations are not implicit. For example, there is a filter. Okay, there are operations for the filter. There are operations for the aggregations. There are operations for the statistical functions. Okay, those operations can be stringed together. Stringed means like you have filter here. Again, you can apply aggregation. Okay, so that way that makes the Spark most expressive. It is easy to perform the data processing tasks in Spark as compared to the MapReduce. Okay, so in MapReduce, we only have to visualize in key value pairs every data processing task. That is not the case here. Okay, that is one of the important advantages of the Spark. Okay, so as Anna said, Spark is also called as in-memory processing tool. In-memory processing tool. Okay, the reason being, by taking the same example as we did in MapReduce, assuming that you have a data in one of your disk, okay, that data has two steps, iteration one, rather step one and step two. Now, after step one, you have intermediate results which need to be funneled into the iteration 2 or step 2. So instead of writing these intermediate results in a disk, they are stored in a memory. They are stored in a memory. Okay. And the intermediate results are stored in a memory and they are funneled immediately into the step 2. This saves lot of time of writing into the disk and reading from a disk. So any data which is available in a memory, it is easy to access. It is readily available for you. Okay. Because of this, Spark is much faster than MapReduce. Okay. Much faster than MapReduce. You guys got it? This is one of the important advantages of Spark. You guys got it? Any questions here from anyone? Shabna, you got it? Vineet, you got it?
Yes, sir.
It is also called as in-memory processing tool. If you remember, when I was introducing the different tools in the Hadoop ecosystem, I mentioned Spark as one of the in-memory processing tool because the way it stores the intermediate results in the memory and funnels them to the next steps, that is the reason it is called as a in-memory processing tool. Okay. Then, as I think somebody said that, Anna or Vineet, one of them said, the Spark can take care of the batch processing also. When I say batch processing, the data is already stored. In a way, historical data. It can process the historical data. It can do the batch processing. It supports the stream processing also. Means as and when the data is arriving, Spark will be able to process it and can send it to the applications or a visualization layer. Okay. And one more important thing is it has a wonderful interactive shell. Okay. Mostly you will not be using it, but if you see my videos in YouTube, I have been using the interactive shell a lot earlier, but these days I am also using the Jupyter notebook. Okay. For showing you, when maybe in the next class I'll show you how the interactive shell will be there. Okay. So this has an interactive shell, unlike the MapReduce. And very important thing, unlike MapReduce, Spark has a support for Scala, Java, Python, SQL, and R. If you know any one of these languages, you can work in Spark. So at least as a part of this course, we'll be introducing you to the PySpark. That is a Spark using a Python. Okay. So this is one of the important advantage. So all these are the advantages of Spark over MapReduce. Make sense? Any questions here from anyone?
Sir, either SQL or Python is enough to work with Spark?
Yes. You need not know Java or Scala. If you know Python and SQL is anyway, it is easy, right? As compared to any other language, it is easy. So the next best the language which is easy is Python. Okay. If you pick up both of them, you'll be able to You'll be able to work in Spark. Okay. Any other questions? Okay. If there are no questions, we'll move forward. Okay. I am talking about shortcomings of MapReduce, advantages of Spark. But what is Spark? What the heck is Spark? Anyone? What is Spark?
Distributed processing model, sir.
Very good. That is one of the way to define Spark. Wonderful. Distributed processing model or a distributed processing platform. Okay. Anyone else?
Programming model. Yes. Anything else?
So used for processing big data.
Awesome. Very good. Different perspective. Okay. So Spark is a unified computing engine and a set of libraries for parallel data processing on computer clusters. That is Spark. So, any one of you here, have you guys dissected any either a cockroach or some frog, or during your +2 days? Anyone? No one here?
Sir, my teacher
Yes, sir.
dissected and we watched it. That's
You watched
sir.
it. That's it. Okay. Okay.
Yeah.
You have not dissected, is it?
No, we didn't. I didn't do it.
Okay, got you. Okay. So, are you guys okay to dissect the definition here?
Yeah.
Yes,
Let us
sir.
dissect this definition. Okay. And understand Spark in a bit more detail. Okay. So, I'm saying Spark is unified. Spark is unified. It is a unified computing engine. Unified computing. One aspect is unified. The reason I am saying that is, before Spark came into picture, different aspects of the data processing was done by different tools, different platforms, different models. But the creators of the Spark, they started providing different aspects of the data processing as a part of one tool or one platform. Different aspects are, let us say, if you want to perform the data analysis, you can use Spark. Let us say, if you want to do the processing as a part of the ETL, you can use Spark. Let us say, if you want to perform the machine learning, you can use Spark. Let us say, if you have to do the stream processing, you can use Spark. On top of that, it's like a icing on the cake. It also has a API to support multiple languages, as we already discussed, Java, Python. So, under one umbrella, you have multiple aspects of the data processing can be taken care. That is the reason it is called as a unified. Okay, that is the reason it is called as a unified. Okay, then any idea why we call it as a only computing engine, unified computing engine? Computing engine. If you refer back to your definition, it says computing engine. Why computing engine? Any thoughts from anyone? Anna, why computing engine? Just take a stab at it. I mean, it's okay. It's not, just say whatever comes to your mind. I mean, I'm here to teach that. Okay. Because, yeah, sorry, go ahead.
Computing means processing or calculating.
Correct. Absolutely right. Absolutely right. But why only computing engine? Because,
Sir,
yeah,
because
yeah,
engine needs to run on something like wheels.
got you. Okay. That's a good try. The reason why we are saying computing engineer is it only worries about the processing.
Yes, sir. Yes, sir.
Spark is only for the processing of the data. It will not worry about the storage. Okay. Spark will not store the data. So it performs the computations on it. It performs the processing on it. But it will never store the data. Okay. For storing the data, it uses HDFS or Amazon S3 or whatever the data storage, data lake, all those things, storage systems are used for the storage. So that is the reason it is called as a computing engine. Computing engine for processing. It limits itself to the processing. That is the reason it is called as a computing engine. Okay. And it has different libraries. Okay. Libraries. Some of them are standard libraries. Libraries for the Spark SQL, Spark machine learning library, GraphX for the graphical processing, Spark streaming library for streaming processing. Okay. It has libraries. Okay. And also it is open source tool managed by which organization?
Apache.
Apache.org. Managed by Apache.org. Okay. So it is managed by Apache.org. So just look at your definition. Spark is a unified computing engine and set of libraries for parallel data processing. We already understood parallel data processing, right?
Yes.
Right,
Yes, sir.
Anna? We did understand the parallel data processing, right? Parveen?
Yes, sir.
On computer clusters means, what is computer clusters?
clusters.
Normal computers are connected together.
Okay, absolutely. Right? See, everything is coming together now, right? What are we
Yeah.
have discussed in the previous classes? Because we discussed those things earlier, you are able to easily understand this concept, isn't it? Right? So that is the beauty of foundation. That is the reason always people say, have a very good foundation, have a very good foundation. We have laid a very good foundation now. We can build on top of that now. Okay. Now, if I start teaching also, you'll be able to explore on your own. I mean, anyway, I'll teach, but there is a proper sequence of steps we have learned now. Okay.